Hello and welcome to section 5.3. This will be our introduction to trig graphs, and specifically within section 5.3 we'll be focusing on the sine curve and the cosine curve, two that you will continue to see throughout the semester. So if at any point in this video series for section 5.3 there's some confusion, I would go back, rewind, rewatch the video. Certainly come to office hours, ask questions in class, because this will be repeated over and over throughout the semester. This is the first video of 3 parts for section 5.3. So again, section 5.3 is our start of trig graphs. And specifically, we're going to be looking at sine and cosine. So first, definition or some information about these graphs. The functions sine and cosine have period two pi. What does this mean? Basically, by period of 2 pi means that for the sine curve or for the cosine curve to make one complete cycle, it is taking a distance of 2 pi around that unit circle. So in general, we can write it sine of t plus 2 pi is equal to the same thing as sine of t. We saw this in section 5.1. If we started at some point on the circle, if you went a full time around, you ended at the same spot. So if, for instance, we had sine of pi, it was the same as sine of 3 pi, sine of 5 pi. You could keep adding the value of 2 pi to it and get the same value, and that's again because it has a period of 2 pi. And similarly, cosine of t plus 2 pi is the same thing as cosine of t. So, what do these graphs look like? If you need to pause it, get caught up with the writing, go ahead. So first, let's look at the graph of sine of t. So let's reproduce our unit circle. And so my guess is by the end of the semester, you'll know what the sine curve and you'll know what the cosine curve look like. Again, that's how much we're going to use it. But let's say it's the final exam and you freeze up and you can't remember, okay, does sine start at 0 or does sine start at 1? You can reproduce it by use of the unit circle. So remember, on the unit circle, the sine of t is what? It's our y value. So I'm going to draw sort of an xy graph here, but obviously my value for x is a lot longer because we're just going to be focusing on the right portion right now. When I am at 0 radians, my value for sine is what? It's 0. So if this line here, if my x-axis is the radians, at 0 radians, I'm 0 units up or down. As I move around the unit circle, when I get to here, to pi over 2, so when I'm pi over 2 radians away, well, how far, what's my value for y? My value for y is 1. So that puts me here. So at pi over 2 radians, I'm 1 unit away from the origin. My value is for y is 1. As I continue back around, what's the next main value I hit? It's pi. So at pi, what's my y value? Well, again, it's 0. So I've come back down to my axis here. If I continue around, what do I hit down here? Well, that's 3 pi over 2. And my value for y at 3 pi over 2 is what? It's minus 1. brings me down here. And now I come around, I've completed one entire period, one entire cycle, which gets me back to 2 pi and back to 0. So if I were to connect these dots, this gives me the graph of sine of t. You will notice, even though it's not the greatest drawing, there's no sharp points on this. So when you're drawing a graph for sine or for cosine or any of your trig functions, this isn't like kindergarten where it's connect the dots. That does not count. You cannot have these points at these different locations on the graph. So it's a nice smooth curve as best as you can make it, getting it through those points. And again, you can see that our entire period here, so to go one complete cycle, is a distance of 2 pi. So that's our graph, basic graph of sine of t. It keeps going to the right, it keeps going to the left. This is just one period that we're looking at. What about cosine of t? So again, we'll draw this same sort of sideways cross. We're going to go as high as 1 and as low as -1 this time. Again, cosine of t is what? That's our x values. So again, I'm going to use the unit circle. When I'm at 0 radians, which is my starting point, what's my x value? Well, it's +1. So I'm not starting at the origin anymore. I'm actually starting up here at 1 unit away from the x-axis, the radian axis. I'll still have these same spots along the graph, so pi over 2, and pi, and 3 pi over 2, and 2 pi. So get in the habit of writing these out, as those are the 5 main points that you're going to plot out. And the reason is that when we start doing transformations of these graphs, if we start with these values, we can make our changes off of these values, and it'll give us exactly where the graph is crossing. So we kind of want to always do that. Instead of writing 1, 2, 3, 4, 5 like we would on a normal graph, we're going to do pi over 2, pi, 3 pi over 2, and 2 pi. So at pi over 2, which is up here, what's my x value? Well, I'm not moving left or right, so it's 0. So I'm actually on the axis at this point. As I come around and I hit pi, what's my value for x? Well, it's -1. So I'm actually bottoming out here at the value of pi radians. 3 pi over 2, I'm back to 0. And 2 pi, I'm back to 1. So again, maybe the dots look like it's formed a V. This is not a V, it's still a curve. So you need to curve through pi over 2, put a little bottom on it, curve through 3 pi over 2, and end back at 2 pi. So it almost looks like a flattened out cup. And again, when we're just talking about cosine of t, it has a period of 2 pi. Now, what about transformations? So I want you to think back to the transformations that you did of like the graphs of x squared, or x to the third, or square root of x. Those same properties that you followed back then, whether you were shifting up or down, or shifting left or right, they follow for the trig functions as well. So let's look at one of those examples first before we deal with the trig function. If I had x squared was my function that I was trying to graph. So f of x is x squared. Well, that's what? It's a parabola through the origin. But what if my function was x squared plus 2? So our shortcut for these transformations was what? Well, we're still dealing with the x squared graph, But this plus 2 is telling us what? It's a vertical shift, and because it's plus 2, it means we're moving the entire graph up 2 positions, 2 units. So this solid line is x squared plus 2 versus just x squared, which is centered at the origin. So this vertical shift, horizontal shift, that all applies the same with our trig functions as well when we're doing graphs of trig functions. So let's look at an example. If we want a graph, and the first example is f of x is equal to 2 plus cosine of x. So as with the x squared, the first thing we want to do is deal with just the function itself. And so that's cosine. So that tells us what? That's the one we just got done doing, which starts at 1, bottoms out at -1. We have pi over 2 and pi, 3 pi over 2, and it ends at 2 pi. So the cosine of x, if I do that in black, the black dotted line would have been something like that, right? But this 2 in the front tells me what? It's my vertical shift again. So this means I'm going up 2 units. So every point on here needs to move up 2. So from 1 I move up 2 positions. From 0 I move up 2. From -1 I move up 2. From 0 I move up 2. And from 1 I move up 2. So it still has this same cosine curve shape. The only difference is this 2 in the front has caused the entire graph to move up 2 positions. Again, it's the same as when we were doing x squared, same as when we were doing square root of x. The properties are still the same. The only difference is now we're dealing with a cosine curve or a sine curve. All right, so then we'll leave this one. We'll deal with cosine again. But now let's say we want to graph f of x is minus cosine of x. So again, this kind of forces you to think back a little bit when we had, for instance, minus x squared. And we had to graph that. What happened? Well, it turned it upside down, right? So the same idea here. It's just reflecting it across this x-axis. So if I do this one in blue, instead of being a +1, this has to reflect down to the other side. So it starts at -1. 0 just reflects to 0. This was at -1, it reflects up to +1. Again, 0 stays at 0, +1 reflects down to -1. So it still has this sort of cup shape that we get with cosine. The only difference now is that this one is in blue. The blue one is our minus cosine of x, and it just gives us an upside down cosine curve. All right, so that's the basic on sine of x, or sine of t, and cosine of t or x, depending which variable we're using. Next, in the second part of the video series, we'll get into amplitude, phase shift, and period change. We'll see you there.